The steady decline in the alluvial aquifer, coupled with increasing energy and fertilizer prices, has farmers looking to continuously improve the efficiency of their irrigation practices. Rice producers are no exception to this trend, and increasing numbers are moving towards multiple inlet irrigation. This method, also known as side inlet irrigation, can save farmers 30% or more on water and associated energy cost. These savings largely result from the increased control producers have when it comes to flooding their rice fields. Side inlet irrigation allows for water to be delivered to each individual paddy simultaneously, eliminating the need to overfill the uppermost paddies in order to transfer water to the lower ones. This makes flood management easier to deal with, as well as more energy efficient. Being able to quickly establish a shallow flood across an entire rice field can significantly reduce the amount of time and money spent operating pumps. In addition, producers are finding this method to further lessen their field work, as the number of broken levees tends to decline and in some cases be completely eliminated. Several other important benefits have also been realized in regard to multiple inlet irrigation in rice production. For one, fertilizer efficiency is improved as the simultaneous flooding helps to reduce nitrogen losses. Herbicides may also work better as they can be activated by an even shallow flush during dry years. The use of multiple inlet irrigation may also improve the effectiveness of fertilizer and crop protection products by preventing them from moving between paddies or being displaced off the field altogether. And lastly, farmers are able to minimize the amount of stunted cold water rice associated with conventional irrigation systems. The first step in regard to multiple inlet irrigation is to determine where the tubing will be installed in the field. The placement depends on the location of the well or riser to which the tubing will be attached. Once the best path for the tubing has been determined, dig a shallow 4-inch deep furrow for the tubing to lie in. The furrow should be dug at right angles to the levees. This means that even when the tubing is laid to follow the curve of a field, it must always be made to cross the levee at a 90-degree angle. Be sure to make the furrow wide enough to hold the tubing in place when filled with water. And remember to always place the furrow off the edge of any pad that has side slope that might cause the tubing to twist or roll. In side inlet irrigation, the plastic tubing can be laid along the side or down the middle of a field. A key difference between the side versus middle of the field installations is that the tubing gates would be installed on both sides of the tubing for the middle of the field and only on one side of the tubing for a field side installation. It is also preferable to install small pipes under the tubing to facilitate water flow for a midfield installation. These pipes can consist of 4 to 6 inch corrugated plastic pipe that are placed under the tubing in the bar ditch to allow water to be evenly distributed on both sides of the field. Other than these points, the installation process is basically the same for both applications. The plastic tubing most commonly used for side inlet irrigation has a 15-inch diameter and is 10 mil thick. Tubing thinner than 9 or 10 mils can break and is not recommended. Just as it's common in irrigating other crops with plastic tubing, it is best to first attach the tubing to a section of straight pipe when coming off a riser. This reduces any flapping of the tubing that could cause breakage. Be sure to double the thickness of the tubing for about 6 feet when attaching to the straight pipe. This helps to protect the tubing from normal wear and tear over the season. Notice that these producers have added a flow meter to their setup. A flow meter is a valuable management tool as it measures the amount of irrigation water used during a growing season and can be used to measure the output of a well, which is necessary for optimizing irrigation performance. Here we see tubing being installed down the side of a field in a furrow. There is no need to dig a furrow on top of the levee. As the tubing is unrolled, it is simply laid on top of each levee and into the furrow dug on each side of it. Any tubing roller will work for laying tubing in rice fields. Here, a producer is using a roller built in his own shop. A lightweight utility vehicle does minimal damage to the levee and frees a tractor for other purposes. Make sure that the tubing has good contact with the ground from the top to the bottom of the field and where the tubing crosses over the levees. If there is too much slack in the tubing when the water is turned on, it could create a kink at the levee, potentially causing the tubing to burst. Note that this grower is making sure he is crossing the levee at 90 degrees. This is very important in order to keep the tubing from rolling when it fills with water and goes over the levees. A shovelful of soil every 7 to 10 steps is normally sufficient to hold the tubing down. Continue this process as the tubing crosses each levee and throughout the entire field. To avoid having tubing blown out of place by the wind, do not unroll it faster than it can be held down with soil. Once the tubing is filled with water, it should no longer be vulnerable to the wind. At this point, you are now ready to turn on the well and install the gates in each paddy. The number of gates will vary for each field depending on the size of the individual paddies and the flow rate of the well. If you need help determining these numbers, be sure to visit with a consultant. Punching the tubing and installing the gates is done in one operation with a gate tool. The gates should be installed in the upper half of the tubing at the 10 or 2 o'clock position and should be located in the upper third of the paddy where the irrigation tubing comes over the levee into each paddy. By installing the gates or punching holes in the upper end of the field, more water is retained in the tubing, which helps keep it from floating. Be aware that in larger fields, it is often necessary to close down gates in the upper paddies to have enough water pressure to allow gates to be installed in the paddies lower in the field. If more than one roll of tubing is needed in a field, it might be helpful to finish the run with the next smaller diameter of tubing to prevent it from flapping as it crosses levees, which can cause the tubing to wear thin and develop holes. Another precaution to take when turning on the well for the first time is to search the pipe for any visible pockets of air. Use the point of a metal flag to punch holes in any of these air pockets observed in the tubing. These pockets can cause damage to the tubing during the hot summer months because when the air trapped inside heats up, it expands, thus stretching the plastic out and eventually weakening it. 1 or 2 tiny holes for the air to escape is all that is needed to eliminate this problem. In side inlet irrigation, keeping records of the number of gates or holes in each paddy is important for future reference so you won't have to redesign the field every time you grow rice. Be sure to install the proper number of gates required in each paddy so that the field fills with water evenly. The paddies should all fill at the same rate, thus reaching the desired depth at approximately the same time. If the paddies fill unevenly, close or open the gates as needed. This is an advantage when there are paddies that lose water faster than others because the gates can be adjusted to fill problem paddies with more water. In this case, there may be a need to install more gates to compensate for levee leakage or light textured soils in the field. After the rice harvest has been completed, the used tubing must be spooled up for proper disposal. It should be noted that proper collection and recycling helps to capture the many economic and environmental benefits of side inlet irrigation. Once all the worn tubing has been removed from the field, it should be taken to an appropriate collection site. Manufacturers of irrigation tubing offer recycling programs because it is illegal to burn or bury plastic tubing on the farm, and paying for landfill disposal is expensive. Check with your nearby tubing manufacturer for specific recycling program details. Side inlet rice irrigation isn't much different than furrow irrigation of other crops where plastic tubing is used. There is no single right way to do side inlet irrigation, but there are several key points that must be observed. First and foremost on this list, always keep good records. Keeping detailed records of gates and holes in each paddy of each field is important for future reference so that you won't have to redesign the fields every time you plant rice. Also, be aware of the potential for tubing to roll out of place and become obstructed. This means following the recommendations in this video when it comes to digging a proper furrow and laying the tubing. It's worth repeating again. Always make sure the tubing crosses the levees at 90 degrees. And do not make a furrow across the levees. This is not necessary and only weakens the levee, causing problems later on. Lastly, you must know the total acreage of the field to be irrigated and the flow rate of the well in gallons per minute. You also need to have reasonable estimates of the areas of the individual paddies so as to properly allocate the amount of water being added to the field. Remember, each gate will provide about 60 gallons of water per minute. It takes an experienced crew of 3 about 1 hour to install side inlet irrigation on 40 acres of rice. As with any practice, there's a learning curve for using side inlet irrigation, but the benefits far outweigh the initial hassles and effort. Water, energy, labor, and time are all saved using this technique. Following the guidelines set in this video will help assist you in getting a good start with this conservation practice.